Okay, now that we learned some of the features that Snowflake provides us to help us on our data engineering journey, let's talk a little bit about the architecture, and then we can understand a little bit of the components of Snowflake. So yeah, basically Snowflake provides a very modern platform which is totally self-managed in an easy way to use. Basically, it was actually, I mentioned already, that was born in the cloud. So totally built for the cloud. It was not born as Hadoop that was meant to run on physical servers. There is literally no hardware or anything to select, install, configure, or manage in the way of services, right? So there is also virtually no software to install unless you want to put some add-ons on top of Snowflake to do something different, right? Maintenance, management, upgrades, everything is handled in all the 3 layers infrastructure-wise from Snowflake side, so you don't need to do that, okay? And Snowflake offers a very unique architectures that other systems they can't offer you because they were born in a different world, but Snowflake was born totally in the cloud. And then other systems, they, for example, like Hadoop and Databricks, they usually have either a shared nothing or a shared disk architecture, and they both have pros and cons. And what Snowflake did, Snowflake got inspiration on the pros of both of these 2 kind of architectures to then create their own. So basically what it did, it got basically the easy storage management from shared nothing, because all the data is centralized in our database storage layer. But it also got the benefits of shared disk architecture, which is basically decoupling. When you decouple your data storage from your processing layer, you're decoupling, and then you're having better performance. Basically, Snowflake took those 2 approaches and joined in a single one, because you can do both. You can have everything stored in one place, but also have a decoupled processing layer, which is the query processing layer, with massive parallel processing. Okay, how does Snowflake do that? So primarily, when you select to deploy Snowflake in whatever is the cloud provider you choose, it will create all your sources for you under a VPC, so you're protected, and later on you can even create more networking rules for this, right? And then the biggest deployment of Snowflake on the Snowflake side is the cloud services layer. Cloud services layer is basically also known as the brain of Snowflake, because it basically manages all the authentication and access control. It means when someone trying to authenticate, to log in to Snowflake to access the instance, it's all handled by the cloud services layer, right? Also infrastructure management, everything that you need to run the Snowflake UI and the Snowflake interfaces that you literally see that to use it. Your interface is done by the infrastructure manager. And optimizer, also some part of the Snowflake optimization services, like especially the cache system, they are also handled by the cloud services, because when you query something, it creates a cache and stores the cache temporarily in the cloud services, right? Metadata manager, as I mentioned to you, Snowflake almost record all things that you perform in the instance in metadata tables, which brings to you a very rich and vast amount of metadata about your database that you can take advantage of. It's all handled by the cloud services layer. And yeah, all the security. So when you provision a role, when you provision permissions, everything goes through the cloud services before you checking out if, for example, a role has access to a specific virtual warehouse in the query processing engine, or to a data in a database. It doesn't even go to the database. It checks on the metadata in cloud services if that user and that role has access to the data in virtual warehouses, and then it allows you or not to do that. Okay, this is the very first layer. This is the top layer, the brain of Snowflake, and then we have the second layer, which is the query processing. query processing layer, you can call engine layer, cluster layer, whatever you want. But basically, this is the muscles of Snowflake. This is responsible for processing the data, to allowing you to do basically what we want to do, query in a fast way using massive parallel processing techniques, okay? And it composed basically by nodes that are allocated from Snowflake to you. And then when you ask, for example, to run a query, it goes through the cloud services and it tells you the state of your virtual warehouses, okay? In each compute cluster, for example, each virtual warehouse here, they are totally independent from the other. And then this is some huge advantage that we have in Snowflake, because we can have as much clusters as needed to parallel process many different topics or areas. So for example, a very common scenario is that you have, for example, a transformation virtual warehouse, you have an ingestion virtual warehouse, you have a BI virtual warehouse, you can have multiple virtual warehouses according to your business structure. And this is also easy to separate cost management. But for example, if you have queries running in the transformation warehouse, it does not affect at all what's happening in queries that are running in the ingestion or BI warehouse, for example. They are totally decoupled from each other, but they can at the same time query the same data, right? The centralized repository, which is in the database storage. We're gonna deep dive a bit better in the virtual warehouses, concepts and pricings, okay? And our last layer basically is where our data lives, is where our data resides, right? So when a Snowflake, when you send data to Snowflake, or when you create a new table in Snowflake, this data is allocated and saved in the cloud provider that you choose, but you have zero access to it, because there are a couple of reasons to that. Because first of all is that security. Snowflake must keep your data very secure. Everything it's encrypted. Everything is under a VPC, so it's not accessible from me, from anyone else, from any other user, and just by Snowflake people, okay? And another reason is basically that Snowflake has a very specific format. It's their secret. They don't tell anyone which format they use, but they have their own format that communicate better with the virtual warehouses they have. And then that's why the combination of having a unique virtual warehouse, cluster processing, and a unique format makes Snowflake so powerful. And on top of that, this specific format is much more compressed than other formats. So there are cases, this compression, this file format changing, it's all handled by Snowflake. And this compression also, there are use cases that, for example, someone had in a blob storage, in a object-oriented storage, a file with 1 GB, and when they imported this data one by one, not doing any changes, when they imported this data one by one to Snowflake, they got reduced almost 50% of the size. And this is something that you can test by yourself. Of course, it's not for all cases. The average compression is from 10 to 30%. 30% is an excellent value. 10%, we can say that's an average value of compression. And your data is gonna cost less, okay? And this compression is totally handled by Snowflake. And the thing is, since the storage cost for Snowflake is the same as the storage cost for the for the cloud provider that you have chosen before, and you on top of that you add compression and save smaller files, it means that you probably will end up paying less storage. We know that storage is not a big part of the cost, but you're already saving something, okay? So this is a very interesting feature from Snowflake. So now we understand a bit how the three layers, they connect to each other, and later on we're gonna start working on the three of them and see how do they interact.